Okay, guys, so here we are in section 3.3. We're going to be going through questions 17 through 27. For the first 6 questions, we're actually going to be using the formula y2 minus y1 over x2 minus x1. That is because this is how you find the slope between 2 pairs of points. We're going to be using both pairs of points to be able to find that. Okay, so what we're going to do is I like to label the points so it's a little bit easier. We're going to say that this is x1, and this is y1, and this is x2, and this is y2. So if we do that, then y2 would be 3 minus, and then y1 is negative 2. On the bottom, we have second x. So we're going to do 7 minus 5 there. Okay, and then when we do this out, we're going to do 3 minus 2, which is going to be 3 plus 2. It's going to be 5. And then 7 minus 5 is just 2. So for 17, our answer is just going to be 5 over 2. Okay, going on to 18 here, we're going to be using the same style. So I'm going to label this x1 and y1. It doesn't matter what you label, whichever points you label, just because you're going to get the same answer either way. Make sure that each one is like either 1 or 2. That makes sense. Okay, so then going through the formula here, we're going to have 6 minus 1 on top. And then our x2 is going to be negative 5 and then minus 4. So what we're going to have is a 5 because 6 minus 1. And then negative 5 minus 4 is going to give us a negative 9. So negative 5/9 is going to be our answer there. Okay, so then coming over to 19. Again, I'm going to label the points. So x1 and y1, and then x2 and y2. Okay, so then going through the formula there, we're going to have y2, which is negative 8. And then we're going to minus a negative 1. And then on the bottom, we got a negative 3 and minus 5. So when we do this, we got a negative 8 plus 1. So when that happens, we're actually going to get a negative 7. And then on the bottom, we have negative 3 minus 5, which is going to give us a negative 8. So then that gets rid of the negatives, and we have 7 over 8 left over. So that is the answer for number 19. Coming over to 20, I'm going to use the same labels that were used up here. So y2 is just 3, and then we have a minus 3, and then over negative 2 minus 7. So this one, we have 3 minus 3, which is going to be 0, and then negative 2 minus 7, which is going to be negative 9. Now, whenever you have 0 divided by anything, this is just going to give us a 0 slope. So that is the answer for number 20 there. Okay, going on to 21, we're going to label these again the same way. So we have x1, y1, x2, y2. Let me do it right underneath here for this one. So we got negative 3 minus 2 on top. And then we have 4 minus 5, which is going to just give us a plus in the middle. So we're just going to have negative 5 on top over 9. So it's the same answer as this one, a little bit different way to get there. Okay, so then going on to number 22, we have x1, y1, x2, y2. So then what we're going to do is we're going to have a 5 minus 1 on top and a negative 6 minus negative 6 on bottom, which that's just going to be a plus. What we're going to have is 5 minus 1 on top is 4. And then on the bottom, we have negative 6 plus 6, which is going to just give us a 0. Now, whenever we have a 0 on the bottom, that can never happen. So really what our answer here is going to be is undefined or does not exist. But I usually like an undefined as this one. Okay. Going on to 23, a little bit of a word problem here. So let's see, the road rises 400 feet over a horizontal distance of 6,000 feet. What is the slope of the road? Okay, so some keywords here is rises and then horizontal, as I've underlined. So when it rises 400 feet, really what it's saying is that we're going up 400, and then we're going over a horizontal distance, which is going to be this way, of 6,000 feet. So the slope of this is going to be this line right here. So when we have rise over run, which is how you find the slope based off of a graph, we're just going to use the rise, which is 400, and divide it by the horizontal distance, which is your run, of 6,000. And then we just have to simplify it a little bit more. So I know divide that by 2, you got 2 over 30, and then 1 over 15. So it's 1/15 for 23. All right. So for this next one, we're going to be writing down the parallel and perpendicular slopes. This one, with parallel slopes, it will be a little bit easier than perpendicular, but parallel slopes is pretty much the same slope. So since n is the slope of 4, our parallel line is just going to be 4 as well. So there's the first one. And then to get a perpendicular slope, what we have to do is we actually have to create this into a fraction of 1/4 and make it a negative number. This makes it so that on the graph, you actually have a 90-degree angle when you cross each other. Okay, so negative 1/4 is going to be our perpendicular slope there. Over here, same thing, parallel is going to be the same slope of -3 over 8. The perpendicular slope is going to be a little bit different. We are going to switch this fraction around so that we have 8 over 3, and we're going to change it from a negative to just a positive. So our perpendicular slope is going to be 8 over 3. Okay, so going on to the next section, we have explained the difference between a slope of 0 and an undefined slope. Let me go ahead and change this color so it's easier to see. But we're explaining the difference between the slope of 0 and an undefined slope. We kind of had to deal with this in 20 and 22 up here. But the main difference between it is that a slope of 0 is a horizontal line. So whenever you have a slope of 0, it's going to look something like that. If you have an undefined slope, it's actually going to go up and down in a vertical line. So this is the main difference between the graphs of both a slope of 0 and an undefined slope. And they're also perpendicular slopes because they cross each other at exactly 90 degrees. Okay, so then on to this last one, I'm going to kind of erase some of what's here. We're going to find 2 points of each line and then use these points to find the slope. Okay, so what we're going to do first is we're going to find 2 points, sorry. So to do this, I'm just going to take random numbers that would go easily into these fractions. So a good easy number for this first one would probably be 3, because if we put in 3, it's actually going to cancel out the fraction. So we're going to have x is 3, and let's see what our y is going to be. We're going to be left with 7 minus 8, which is just going to give us a -1. So there's our first point of 2 for this first line. And then what we're going to do is we're going to find another point, another x value that's going to be easy to cancel out, which in this case, I'm just going to stick with multiples of 3. And let's go with 6. So 6 divided by 3 is just going to give us 2 on top. So now we have 14 minus 8, which is just going to give us, sorry, this is 6, which is going to give us a 6 for the y value. Okay, so then taking these points, we're going to find the slope of the line. So I'm going to label this x1, y1, x2, y2. And so what we're going to do is y2, 6 minus -1. So they're going to add on top there. And then 6 minus 3 on the bottom. So then what that comes out to is going to be 7/3. So there's the slope for that one. Okay, then coming over here, we're going to use the same style. So I'm going to use a couple points. Let's say 0 is probably going to be a good one. This one's an easy one because it'll just cancel this entire thing out and give us 4. And then another good point that we could use is 5, because 5 divided by 5 is just going to be 1. So those will cancel out and leave 3 in its place. So then we're going to have 3 plus 4, which is just going to equal 7. Okay, and then using the same thing that we have been using, the slope formula, we're just going to do 7 minus 4. And then we're going to do 5 minus 0. Okay, so then this is going to give us 3/5. And there's our slope for this line. Okay, hope that helps.